talking about tangents today. So I've written up here a number of notes about it. We're going to explore basically 3 processes for finding the equation of a tangent, and then we can use whichever process we prefer. So hopefully we're pretty familiar with tangents already. So we've got a tangent is a line that is parallel to the curve. So if this is the curve, and if you were to zoom in and zoom in and zoom in on that point, if you keep zooming in, eventually there's going to be a straight line there. Okay? And that's what we're doing in calculus. We're finding what is the slope of the line at that point. And so a tangent is a line that is parallel to that point. Okay, so it's going to touch at that point, but it's going to have the same slope as that point does. And then a normal is just a line that's perpendicular. Okay, so tangent parallel, normal perpendicular. And then all we're doing then is finding the equation of a line. That's basically what we're doing here. And so the 3 ways that we can do that are just intuitively finding the equation of a line. We can use general form, or we can use the formula. Okay, so there are 2 formulas for finding the equation of a line, and I list them. They're highlighted in the green there. From this we have the equation for the tangent and normal. So the tangent, f dash of a times x take a. So it's highlighted in the grey there. So I'm going to basically go through an example of each process for you. And I hope we're quite confident at finding the equation of a line in general form. If not, that might be a skill we need to develop a bit. Because really we need to know both. All right, y-intercept form and general form. That's what we're going to be doing here. And then the formula is just sort of a shorthand way, and perhaps a way you don't even have to think about it. You just find the stuff, put it in. So let's get in the first example. We've got the function f of x is the square root of x. And it says find the tangent in y-intercept form at x equals 4. Okay, so to find the equation of a line, we need 2 things. We need the slope, and we need a point, or what we call the point of contact, okay, where the tangent or the normal is touching the curve, the POC. So we can find the point of contact first. That's quite easy. I'm going to leave those 2 spaces blank for now, and let's find the information first, and then let's explore the process for finding the equation of a line. When x is 4, we need to find the corresponding y value. So that means we're finding f of 4, which is the square root of 4, which is 2. So our point of contact is x is 4 and y is 2. Okay, we need to find the slope now. So we've got the point of contact, let's find the slope. Now to find the slope, we're going to find the derivative function and then put x is 4 into the derivative function, because that's going to tell us the slope for any value of x. So f of x is x to the half, and so f dash of x will be half x to the minus half. All right, and so if we were to write that neatly, that's 1 on 2 root x. And so then to find the slope, we're putting x is 4 into the derivative function here. F dash of 4 will be 1 on 2 root 4. That's 1 on 2 times 2. That is 1 on 4. Okay, so we've got our slope, and we've got our point of contact. Okay, so then now when I've written intuitively up here, what I mean is like how you find the equation of a line normally. So that's y-intercept or gradient. What do you call it? Yeah, y-intercept form, general form. So let's find the equation of a line. It has a slope of 1 on 4, and it's going through this point. So remember, the equation of a line in y-intercept form is y equals mx plus c. We've got our value of m, our slope, that's 1 on 4. So we've got y equals 1 on 4 times x plus c. In order to find this value of c, we need to input the point of contact. Okay, we've got y is 2 and x is 4, and then plus c, and then we're just processing this for c. We're going to have 2 equals 1 plus c. C is 1. And therefore the equation of this tangent is 1 of 4x plus 1. Okay, so if you're going to pull your calculator out and sketch the square root of x, and then you're going to sketch this line, you're going to see that tangent, okay? What it'll look like, square root of x looks like this, and the tangent is going to be a line going like that, okay? Just touching the curve parallel at that point. Okay, any questions about that process? All right, so what did we do? We're always finding these two pieces of information, okay? Then I've just said we found those pieces of information, then we're just finding the equation of a line. So we're sort of combining a number of things here. We're combining calculus with finding the equation of a line. Excellent. Let's move on to the next example. So we do have limited whiteboard space. So I'm going to just rub it out. Okay, cool. So I'm going to rub out actually all of that information because some of it is going to remain the same. We did need f dash of x. Okay, because we've got the same function, but this time it says find the equation of the normal in general form. Okay, so we've done part A. Part B, find the equation of the normal at x is 9. So this time we've got a different point of contact. We've got x is 9, and which means the y value is going to be f of 9, or the square root of 9, which is 3. And our slope's going to be different as well, okay? Because what we need to do is we need to find the slope when x is 9, and then we're going to, let's do that first. So that means we're going to find f dash of 9 is 1 on 2 root 9, which is 1 on 2 times 3, which is 1 on 6. Okay, that's fine. All right, that is the slope at x is 9. All right, and we would use that for a tangent, but we are asked to find the normal. And we know that a normal is a line that is perpendicular. So that means we need to find the negative reciprocal of this slope. So that means we flip it and multiply it by -1. All right, so our slope is going to be -6 on top of 1. All right, we can simplify that to -6. So we've got all of the information we need. We've got the slope and the point of contact, and we're just finding the equation of the line. Here it's asking us to do it in general form to familiarise us with that process. So what I'm going to write up here is the flawless rule for general form. So if you have A on B, this is the slope. If slope is A on B, then AX take BY equals C. And if we have minus A on B, then AX plus BY is C. That's how we're processing general form. All right, so up here we've got a slope of -6. Now we want to express it as a fraction so we can recognise which general form we're doing. So we've got -6 on top of 1. And so it's resembling this one here, isn't it? It's a negative slope, and we've got one number on top of the other. So that means we're going to write 6x plus 1y equals c, all right? So the number at the top is the coefficient of x, the number at the bottom is the coefficient of y. 6x plus 1y equals c. Now understand the 1 is obsolete. I'm just putting it up there so you can see how we're tracking from here to here. All right, how we're applying that rule there. Okay, so this is general form. Remember, hopefully we've sort of done this before. It looks pretty familiar. So we've written out this statement, and then we're ready to substitute in the point of contact. All right, so we've got x is 9, y is 3. We're going to have 6 times 9 plus 1 times 3 is equal to this value of c. Let's process that. 9 6s are 54 plus 3. We've got c is 57. So the equation of this line in general form is 6x plus y equals 57. Okay? Now remember, y-intercept form is y equals mx plus c. And so you could rearrange this quite simply to get y by itself. You'd have y equals minus 6x plus 57. All right, so you can just rely on y-intercept form and then convert it to general form, but it just makes things a bit longer. It's better to be competent at both processes. All right, any questions about this one? Okay, so we've got full marks here. We've expressed it as the equation of a line in general form. That's the equation of the normal. Excellent. Okay, so let's move on to, we will do 2 today. We might just do question 2 and then we might stop there for now. All right, so you can just follow the idea like we've been doing it with x, and now we'll do it with a trig function. So see if you can see the relationship. And I'm going to run all this out again. Cool. And maybe we'll use the formula this time. All right, so you can see an application of the formula. So we've seen the first 2 processes, y-intercept form, we saw general form. Let's have a look at the formula. So consider y equals sine x. Find the equation of the normal at x is pi on 3. All right, so before we can use the formula, we still need those 2 pieces of information. What is the slope and what is the point of contact? So let's find the point of contact first. We've got when x is pi on 3, y is going to be sine of pi on 3. And we're going to need to look at our unit circle. Sine is the y values. When the angle is pi on 3, we've got root 3 on 2. All right, so our point of contact, x is pi on 3, y is root 3 on 2. So, the same process applies, all right? The complexity's escalated a little bit because now we're dealing with sort of fractions and surds and trig ratios, but it's exactly the same process. You find this, you find the slope, and then you proceed. So we need to find the slope. All right, so that means we need to find the derivative and then put this x value into the derivative. So dy on dx is going to be cos x. And when x is pi on 3, dy on dx is going to be cos of pi on 3. And again, we're looking at our unit circle for the same angle. What's the value of x? Cos is x. We've got positive half. So we have slope and we have point of contact. Now we're asked to find the normal, aren't we? So it says find the equation of the normal. So let's look at the formula for the normal here. The normal has formula minus 1 on f dash of a times by x take a plus f of a. So let's explain what this means. Okay, a is the x coordinate of the point of contact. Okay, so in this circumstance, our point of contact is pi on 3. So that means we're finding minus 1 on f dash of pi on 3. I'm just going to fill this in to show you what we're doing. X take pi on 3 plus f of pi on 3. All right. Pi on f, the value of a here just means the point of contact. It's the tangent at a, or the normal. The normal at x is a. All right, and then all we need to do is fill these pieces of information in, because f of pi on 3 is, that means the y value when x is pi on 3, that's going to be this one here. All right, so that part there is going to be root 3 on 2. Plus there, we'll just do it a little bit backwards here. And then here we've got minus 1 on top of f dash of pi on 3. That means the slope when x is pi on 3. So we found that already. When x is pi on 3, the slope was half. So we've got minus 1 on top of a half. Okay, and that's times by that, and then plus this. And so really, we've got the whole thing there. Like, you could put that in your calculator, and that's going to be the equation of a line. But we can simplify it. Let's bring it all together, collect like terms, make it look a fair bit neater. So minus 1 divided by half is minus 2. Okay? You can put it in your calculator, or you can go, well, 1 divided by 1, 1 we can write as 1 on 1 on 2, and AD on BC. We've got 2 on top of 1, minus 2. So here we've got minus 2 times x, take pi on 3, plus root 3 on 2. Now when you have a problem like this, there's lots of ways it could be represented. So you might have an answer, and it may be represented a little bit differently in the back of the book. So I'll just show you a couple of ways. Like here you've got 4 marks, all right, because we've simplified it. But it could be like this, it could be minus 2x plus 2 pi on 3 plus root 3 on 2. All right. Remember, it's the equation of a line. Yeah? The equation of a line is y equals mx plus c. So what's our value of m in this circumstance? What's our value of m?
-2.
Yeah, it's the coefficient of x. M is minus 2. And that means this thing here, all right, both of these numbers are irrational. Pi has an infinite number of decimal places, and so does root 3. Root 3 has an infinite number of decimal places. So this is just our y-intercept, but we've represented it exactly. It's the exact value of the y-intercept. You know, and you could collect them by making them have the same denominator. All right, you could write it like minus 2x plus, we'd have 4 pi plus 3 root 3 on top of 6. All right, but you know, you don't need to. That's the y-intercept. Here it's got the same value, just a different way of representing it. And so, let's summarize. So we always need these 2 pieces of information, okay? And then all you're doing is finding the equation of a line. Is it parallel? Okay. Tangents are parallel. They have the same slope. Normals are perpendicular. They have the negative reciprocal slope. Which is why, in the formula here, it's minus 1 on f dash of a. That's performing that negative reciprocal aspect of it. All right? So you can use any process you like, okay? Unless it specifically says to use general form or use y-intercept form, which it does very rarely. So that's enough to get started on tangents. That's exercise 3A. Yeah, let's spend a bit of time doing it, and then we will talk about the test today.
You talked about